My name is Hanna Björk. I'm Head of Sustainability at Västtrafik, and we are responsible for the public transport in the region of Västra Götaland. We have political targets of climate, and we shall reduce the CO2 emission by 90% between 2006 and 2035. Today, we have reduced the CO2 emission with 71%. We started with pilot projects, and we have tested in electricity, which is a huge project, and we there had special routes for electric buses. We learned a lot, and also we got the courage to procure electric buses because the project showed us it's possible to use e-buses in city traffic. In December 2020, we started the first real contract with e-buses, which we had procured as e-buses. 145 e-buses started traffic in the city center of Gothenburg, Mölndal och Partille.
I'm Peter Nordin, Electromobility Director at Volvo Buses. I've been running the electricity collaboration for Volvo Buses and from Volvo perspective since 2016. We delivered 145 electric buses on a single day, and they were put into operation the very same day. So that was a quite a huge challenge to have that delivery of all the vehicles on one single day.
This 145 buses were the starting position of our large-scale electrification. Our goal is to electrify all city traffic in our region at 2030, and we are on our way. Today we have almost 500 e-buses in our traffic. There have been a lot of shared knowledge, which the pilot projects have helped us with, and also showed us that it's possible to work together with the energy company, with the grid owner, with the municipality, and also with the traffic operators, because all of these stakeholders are necessary for doing this electrification.
We have been running the electricity cooperation since 2015. We put the first buses into operation, and by that cooperation, the different partners get confidence and trust in an electric bus system, and that led to that it was possible to proceed with a full-scale implementation here in Gothenburg. Based on the experience from the electricity cooperation, it was possible to perform this large-scale implementation earlier than it would have been possible otherwise. The valuable input that we see that was important was not only the vehicle and the vehicle-related services, it was also the charging strategies and the grid connection perspectives. But we also saw that it was important to understand the urban development aspects and both the citizen and passenger perception of this e-bus system.
My name is Henrik Pamp. I'm General Manager here at Transdev, Gothenburg. Transdev is today the biggest private-owned public transportation company. And we are close to 120,000 employees throughout the world. So it's a big company. In 2020, we started new contracts and we are running 160 electric buses today. And the main challenge when we started was mostly that it was a new technology, that we had to educate ourselves, and we had the bus drivers for the new buses. We had to educate our technicians for the maintenance, especially with the new buses. And also we had to think in a different way regarding traffic planning. We were used obviously for diesel buses, which was the common buses in 2020. When we went to electric buses, we had to include charging stops in the city during the day, and that's a complicating factor. So that was, for planning, that was the main difficulty that we had to solve.
We see that opportunity charging is not only up-charge or pantograph charging. Opportunity charging can, based on the specific situation, be automatic connections like up-charge or other automatic solutions, but also cable connections. It depends on the specific operation, depending on the time, the sites, and so on. But there are a number of different aspects that needs to be taken into account when defining the charging strategy. Having large depots with only depot overnight charging, that will require large grid connections. But if you also combine it with en route charging during the day, you will distribute the charging power, the needed power, over time, but also over a geographical area. One other important aspect when it comes to charging and the charging strategy is to consider the resilience and robustness. If you have one large depot with one single grid connection, you will have a single point of failure. By having a distributed charging solution, you will not be that vulnerable to power outages and other fault in the charging systems.
Depot location is extremely important for all bus operations because obviously we want to minimize the time that we are running with empty buses. So the depot needs to be situated in a place that is optimal for the traffic that you are running. The ownership of the depot is important. There are two options: either each operator owns and runs their own depot, or the PTA, in this case Västtrafik, owns the depot. And that means that there is usually one or maybe two locations that is optimal. So the operator that has control of these depots have a big benefit when they are leaving a tender.
My name is Cecilia Järnehem, and I'm a business area manager for Nobina, and I'm responsible for 5 traffic areas. Today we operate around 450 electrical vehicles, and here in Gothenburg we have around 150. It's a much more complex operation to run, both from the PTA side and also from the operator side. Everything around planning, technical infrastructure, monitoring, and competence, because today it's a kind of lack of competence around electrical vehicles. So you have to train and to educate both the drivers and also the mechanics to be able to take care of this new type of buses. You have to be aware early who is responsible for what. That's very, very important. Before, when you don't drive electrical vehicles, the PTAs were not that involved when it was kind of a crisis situation. It was more or less always the operator's responsibility to fuel the vehicles or take care of a fire or whatever the crisis was about. But now, when we have electrical vehicles, the PTAs has a much bigger responsibility, mostly for the technical infrastructure, and they are not always aware of that. I think we are gaining experience every day, and also everything develops in a very, very high speed in, for example, capacity of battery or charging technology. So it moves very, very fast in the whole of the electrical vehicle branch, so to speak.
My name is Carl Orton. I'm the fleet director for Keolis in Sweden. We have 1,600 buses. 150 of them are electrical today. We've ordered another 185 that will arrive this year, and an additional 170 that will arrive in 2025. So we are on our way very quickly to a high degree of electrification in our fleets. Some of the learnings that we have had that have been major for us when we go with 100% electrical fleet is the impact on weather, the outdoor temperature. We live in the Nordic countries. The weather can get very cold in the winter time. This winter, 2023-2024, was the coldest winter in many, many years. And the first time we had both a very cold winter and 100% electrical fleets. Many operators couldn't anticipate the problems that would arrive. And I think the whole industry has learned a lot of how you dimension your system to make it work also for the extremes. When it comes to electrification, and if you do not want the cost to explode and you want to optimize so that you have the optimum amount of chargers, the optimum amount of vehicles, as low battery capacity as you need, because you want to optimize also the costs, then you're going to need information. You're collecting data from the vehicle, you're collecting data from the charging infrastructure, you're collecting data from the traffic, and you're also collecting data from your traffic plans. All of this data has to be consolidated and presented to the people so that they can make the right decisions. This is also something very new that we have learned that was not really on the table when we were doing the electricity project, because there was only 5 or 6 buses. Now we're talking hundreds, and with that amount of information, no human being can optimize it. We need data, and we need software, and we need computers to help us make the right choices.
My name is Peter Lindgren. I work for the city of Gothenburg as an electrification strategist. So I've been working with electric buses since 2017 when I joined the city. For the city of Gothenburg, electric buses are important for the local environment. They do not produce local pollutions, and they are very quiet. We also benefit from the lower carbon dioxide emissions for our environmental program. If you're about to introduce electric buses in your city, you need to do your homework. You need to talk to several suppliers, and you need to check that these buses will work in all conditions, not just only in the normal way. We need to know that it works in very hot weather, very cool weather, when it rains and so on. When preparing for the electric bus traffic, you need to make sure that you have enough time to build the infrastructure needed. For example, to get building permits and to get the hardware in place.
Previously, 1 year between signing the contract and starting the traffic has been more common. And when we are going electric, 1.5 years is needed to get everything in place. You need the depot, you need the charging opportunities, and you need, of course, the buses.
One of the most important things is to have the end-to-end perspective and to see it from a system perspective. You have vehicles, you have charging infrastructure and grid connection, and you have charging management systems as well as other things in this. But you have to have this end-to-end perspective in order to secure this large-scale implementation. If you are a partner working with one of these, you need to have the system view or end-to-end perspective as well in order to understand how your part is actually contributing to the entire system. That is really important.
We are extremely satisfied for going electric in city traffic. We also know that the drivers are satisfied and the people living along the lines are satisfied. We have reduced the low frequency noise within the places where people live, and they are less disturbed by the traffic. We have seen that going electric in city traffic is no problem today. Actually, there is no higher costs for going electric in city traffic compared to traditional combustion engines. But we also want to go electric in the regional traffic, but there is a lack of vehicles suitable for our traffic today. Hopefully, in a couple of years, there will be vehicles on the market, so we can go electric in the whole region.
Operation of an electrical bus is easier and much more pleasant, and it's also more silent, so the drivers are not willing to drive anything else than electric buses today.
From a city perspective, we see that electric buses are beneficial for the city. The disadvantages are much fewer than the advantages, so we would recommend to make all efforts to get electric buses into your system.